So today's lecture is about vectors, and this is first lecture of vectors. So in this lecture we are going to have all the basics which are required for learning vectors. Vector is a very essential topic for the reason in higher studies when you go for engineering you require a lot of concepts with regard to vectors. So let us begin with vectors. So this lecture of vectors, I will teach you first basics. Now when I say basics, it will start with the definition. It will start with definition. Then you will have type of vectors, types. Then you have the algebra of vectors. Algebra of vectors, that is addition, subtraction. Then you will have multiplication of vectors, that is scalar product of two vectors. You will have multiplication of vectors. That is scalar product of two vectors. Vector product of two vectors, which you call dot product. And then you call it, then the next one you call cross product. Dot product of two vectors, cross product of two vectors. After that, you will have the scalar triple product, vector triple product. And then you have application of vectors to geometry. So this one is going to be a session of minimum 10 hours. In 10 hours, I will try to complete this vectors. After that, we will have direction ratios of a vector, direction cosines of a vector. Then we will have lines, plane, all that in the next topic. So in this topic, in this chapter, we have basics of vectors and whatever I said just now, all that we are going to see. So the first thing is, let us define a vector. What is a vector? Definition. Define, okay, a vector. So we will write a physical quantity which can be completely expressed, completely expressed by its magnitude and direction is known as a vector quantity. And you already know what is a scalar quantity. A scalar quantity is a quantity which can be expressed with the help of its magnitude only. A scalar quantity is a physical quantity which can be expressed with the help of its magnitude only. You don't need direction. You only need the magnitude. Magnitude means number, a simple number. For example, if I say time, time is 2 hours. So what is 2? 2 is a number. Okay, that is the magnitude. 2 is a number, it is magnitude. So you can express time with the help of a number only. Do you need a direction here for expressing time? Do you need a direction? No. Direction is not required here. Direction is not required. So time is a scalar quantity. It is a scalar quantity. Remember, it is a scalar quantity. But think of force. Think of force, a physical quantity, force. I have an object kept here. I have an object which is resting on the surface, this surface. Now I have a force, and that force is applied in this direction. Okay. I have a force of a particular magnitude, and I apply that force in this direction. What will happen? This direction, if I apply, the object will move. The object will start moving this way. The object will start moving this way. But remember, if I apply the same force, if I apply the force of same magnitude, if I apply the force of same magnitude from this direction, same magnitude, what will happen? Object will start moving this way. So what you notice? You noticed that force is a physical quantity which is requiring, along with its magnitude, also the direction. If you say force, so force has a particular magnitude, say 5 Newton, 6 Newton. So the force which has a particular magnitude, you will also have to describe the direction of that force, which direction the force is applied, in which direction the force is being applied. So force requires, along with its magnitude, that is, say, if I say this force is 5 Newton force and its direction is towards left, the direction is what the arrow shows. The direction is what the arrow is showing. The direction is what the arrow is showing. So what you saw that force requires magnitude, and along with magnitude it also requires direction. And hence what you call this as vector quantity. Force is a vector quantity. Okay, force is a vector quantity. So let us read it once again. A physical quantity which can be completely expressed by its magnitude and direction is known as a vector quantity. Now we will write the example. For example, just now I wrote force, velocity, acceleration, electric field potential, etc. So now you understood what is a vector quantity. We will go for the representation of a vector. How is a vector denoted? Let's see how is a vector denoted. So I will write here a vector. See, on a piece of paper, or on a board, if I want to study vectors, I need to first represent vectors. Okay, so how will I represent a vector? A vector is denoted by a directed line segment. It is denoted by a directed line segment. A vector is denoted by a directed line segment. Okay, so here let me show a vector here. See, this is a vector. This is a vector. Now in this you will have a initial point. So this point is initial point from where the vector starts, A. This is the terminal point, B. Okay. You can have the arrow. Here I have the arrow. Here I have drawn the arrow at the end of the vector. At the end of the vector. You can also have the arrow somewhere in between. That is okay. That is no problem. You can also have the arrow somewhere in between. Here you can have the arrow. Okay. No worries. So this is also, you can have an arrow somewhere in between. This direction of arrow, the direction in which arrow goes, it shows the direction of the vector. So right now the direction of the vector is this way. This is the direction of the vector. This is the direction of the vector. Okay. So here in this directed line segment, you see A. A is the initial point from where the vector originates, the vector starts. B is the terminal point where the vector ends. And now this vector I'll be writing as vector AB bar. It is vector AB bar. And this arrow shows the direction of the vector. What is point A? A is initial point. A is initial point of the vector. A is initial point of vector AB bar. You call this as AB bar. What is the name of this vector? You call this as AB bar. B is terminal point. It is terminal point of vector AB bar. Now see, this vector will have some length. This vector will have some length. What is length of this vector? The length of the vector will be measured this way. See, from here, the length of the vector will be measured from here to here. See, this length of the vector is this. See, this is the length of the vector. This length of the vector is the magnitude of vector AB bar. How big is AB bar? Suppose the length of this vector AB bar comes out to be 9 centimeters. 9 centimeters. So I will write magnitude of vector AB bar. Magnitude of vector AB bar equals to 9 centimeter. And symbolically, we will write this as mod of AB bar is 9 centimeters. See, mod AB bar, mod. Magnitude of a vector is represented by mod of that vector. And what is magnitude actually? So you understood that magnitude of this vector is nothing but the distance between its initial point and its terminal point. You understand that magnitude of a vector is nothing but the distance between the initial point and the terminal point of the vector. Magnitude of a vector is distance between, we can write it here. Magnitude of a vector is distance between initial point and terminal point of vector. Terminal point of vector. So the distance between A and B is mod of AB bar. Is mod of AB bar. So the next we are going to have after this, now we shall start with types of vectors. Let us write few types of vectors. Types of vectors. So in types of vectors, first I shall do zero vector. I will teach you zero vector. Then next I will teach you unit vector. Unit vector. Then I will teach you parallel vectors. I will teach you parallel vectors or collinear vectors. Parallel vectors or collinear vectors. I will teach you coplanar vectors. Coplanar vectors. Then I will teach you equal vectors. So these are some basic types of vectors. These are some basic type of vectors that we have to see. So let us start with a zero vector. What is a zero vector? Let's start with a zero vector. So here I have a zero vector. See here. A vector having zero magnitude or no magnitude. A vector having zero magnitude or no magnitude is known as a zero vector. It is known as a zero vector. A vector having zero magnitude or no magnitude is known as a zero vector. Now let me show you something here. Suppose I have here a point. I have a point here. I have a point here. You see this? This is the point. Now from there, see from there, if I start in any direction, see, if I start in any direction, then what you notice is If I start in any of the direction, what you notice is that you have a vector. See, and this will have, no matter how small it is, see how small it is, no matter how tiny I take. So this will definitely have some magnitude. This vector will definitely have some magnitude because it has an initial point and it has a terminal point. It has some initial point, it has some terminal point. So definitely there is some distance between them. So it has some magnitude. This vector is a small vector, but it is not a zero vector. What is a zero vector? A vector which has zero magnitude. So you can say a zero vector is nothing but a point only. A zero vector is nothing but a point only. And a zero vector, since it does not have a magnitude, it is a zero vector. It has zero magnitude. A zero vector as such, its direction is not defined. Okay, it can be in any direction. A zero vector can be in any direction. It doesn't have a specific direction. A zero vector does not have a specific direction. It can be in any direction. Okay, so you understood what is a zero vector? A zero vector is denoted by zero bar. Okay, a zero vector is denoted by a zero vector is denoted by zero bar. What have you written? You wrote zero and then you wrote this bar. This bar is actually an arrow, you know, zero and then arrow. Here also, here I wrote AB bar. This AB bar is nothing but AB and then an arrow. But then you could draw an arrow or you can simply put a line here. You can simply put a line. So what we prefer putting a line instead of putting an arrow. You got that? So here zero bar. What is it? It is zero bar. So it is denoted by zero bar. So you got what is a zero vector. Now after that, after zero vector, the next we have is a unit vector. Okay, so second. We are now going for a unit vector, which is second. What is a unit vector? See, a vector having magnitude equal to 1 unit. A vector having magnitude equal to 1 unit is known as a unit vector. It is known as a unit vector. A vector having magnitude equal to 1 unit. How much is its magnitude? The magnitude is equal to 1 unit. It is known as a unit vector. It is known as a unit vector. A unit vector is denoted by cap. So here I will write a unit vector. A unit vector is denoted by E cap or N cap or P cap. You know, you write a small letter and then write cap. Yeah, there is one more thing which I forgot to tell you. Let me now take it. See, when we said representation of a vector, I wrote AB bar. Now see, this vector is AB bar because it has initial point as A and it has terminal point as B. So you call this as AB bar, vector AB bar. There is one more way of representation of there is one more way of writing this vector. Here I used two capital letters for writing the vector. See, I wrote AB bar. I used two capital letters. That is one capital letter A, which is representing the initial point of the vector, and the another capital letter B, which is representing the terminal point of the vector. So I write it as AB bar. Remember, you cannot use small letters for writing the initial point and the terminal point of a vector. You cannot use small letters. These points are to be represented only by capital letters. Okay. Now there is one more way of writing this vector. I could have simply said P bar. Okay, this vector AB bar. This vector AB bar, I can simply write as P bar. I can say let AB bar equals to P bar. This is also allowed. Okay, this is also one way of writing the vector by a single letter. So the vector AB bar, which I represented by writing its initial point and the terminal point as A and B, and then that is AB bar. The vector AB bar, I could simply write as P bar. Now, when I'm using a single letter, remember that single letter has to be a small letter. The single letter has to be a small letter. So when you are using two letters, you are using both the letters as the capital letters. But when you're using single letter, that single letter has to be a small letter, small alphabetical letter, P bar, P bar. Okay. Now that's up to you. I chose P bar. You can have simply, you could say M bar, M bar. Let this vector be M bar. Okay. So this is another way of writing the vector. So here we were doing unit vector. A vector having magnitude equal to 1 unit is known as a unit vector. A unit vector is denoted by E cap or N cap or P cap. What is magnitude of a unit vector? Magnitude of unit vector is always equal to 1. Magnitude of unit vector is equal to 1. So as we are writing these all as unit vectors, needless to say that we will have mod of E cap equals to 1, mod of N cap equals to 1, mod of P cap equals to 1. They will all have their magnitude equals to 1. They will have magnitude equals to 1. Okay. Remember, the unit vector can have direction anywhere. It can have any direction. Okay. It is just a unit vector. Suppose if I say this big is a unit vector. See, if I say this big is a unit vector, this is 1 unit. Say this is 1 unit. Now 1 unit, this is unit vector. Now see, it can have any direction. See, they all are 1 unit. And it can be in any direction. It is a unit vector and it can be in any direction. Okay. After unit vectors, let us have parallel vectors or collinear vectors. parallel vectors or collinear vectors. So let me now teach you parallel vectors or collinear vectors. See, two vectors having same direction, or opposite directions. Two vectors having same direction or opposite directions are known as parallel vectors or collinear vectors. They are known as parallel vectors or collinear. Two vectors having same direction or opposite directions, they are known as parallel vectors or collinear vectors. See, for example, let's have examples here. So I have one vector here and see the another vector here. Now these two vectors have same direction. They have same direction. They are in the same direction. They have same direction. You can check. They have same direction. Both are going in the same direction. They will never be able to cross each other. They cannot cross each other. They will never be able to intersect each other. The distance between them will always remain same. They are in the same direction. They are known as parallel vectors. What are they? They are parallel vectors or collinear vectors. Parallel vectors or collinear vectors. I can call this as A bar and B bar. Okay, A bar and B bar. A bar and B bar. A bar and B bar are parallel vectors. Okay. Now let's have another example here. Let's have another example. See, I have a vector here P bar, and then I have another vector Q bar. I have two vectors here. One is A bar and the other is, one is P bar and the other is Q bar. Vector P bar, vector Q bar. What do you see? You see that vector P bar and Q bar have opposite directions. They are in opposite direction. You can check the direction. Look at the arrow. Look at the arrow. P bar is going in this direction and Q bar is going in opposite direction. They have opposite direction. So what will I write here? I will write here vectors. I will write here vectors P bar and Q bar have opposite directions. Opposite. They have opposite directions. Okay. But they are still parallel. You can check. They are still parallel. As A bar and B bar were parallel, P bar and Q bar are also parallel. So what will you say? You will say that P bar and Q bar have opposite direction, and you will say P bar and Q bar are parallel vectors. They are parallel vectors. I hope it's clear to you all. Next one is coplanar vectors. After parallel or collinear vectors, we are now going for coplanar vectors. Let's do coplanar vectors. What are coplanar vectors? See, here I define a plane. What I have defined is plane. I define a plane. Now in this plane, I'm keeping some vectors. See, these all vectors are in one plane. They all are in one plane. Vector A bar, vector B bar, C bar, D bar. These all vectors, they lie in one plane. Okay. So what we will call them as coplanar vectors. Vectors lying in one plane are known as coplanar vectors. But there is one more case which I shall bring to your notice. Suppose here I have okay, here what I said for this A bar, B bar, C bar, D bar, what did I say? I said that all these vectors, they lie in a single plane. They lie in one plane. So as they are lying in one single plane, they are known as coplanar vectors, coplanar vectors. Now here there is one more case which I shall bring to your notice. Okay. Let me name these two planes. I have two planes now. This one I call this as alpha plane and this is say beta plane. Okay. One plane is alpha plane and the other is beta plane. And what I notice is these two planes are parallel planes. Alpha plane and beta plane, they are parallel to each other. They are parallel planes. Like in your home, you have floor and you have ceiling. Okay. In your home, you have floor and you have ceiling. On the floor, you lay the carpet. And on the ceiling, the fan is hanging. The fan is hanging over your head. You walk on the floor, and the fan is hanging over your head on the ceiling. Okay. So these two planes, as the floor and the ceiling are parallel to each other, the floor and the ceiling are parallel to each other. These two planes are parallel to each other. So I have here alpha plane and beta plane. See, there is one vector in alpha plane and there is another vector in beta plane. Okay. As the two vectors are lying in two parallel planes. Okay, suppose if I call this as vector P bar, I call this as vector P bar and this one I call it as vector Q bar. Now vector P bar and Q bar, they are lying in parallel planes. They are lying in parallel planes. So they are also coplanar vectors. So how do we define coplanar vectors? How do we define coplanar vectors? We will write here vectors lying in same plane, vectors lying in same plane or parallel planes or parallel planes or parallel planes. are known as vectors lying in same plane or parallel planes are known as coplanar vectors. They are known as coplanar vectors. Now the last one is equal vectors. I have to teach you equal vectors. The fifth is equal vector. What are known, which vectors are known as equal vectors? So here I write equal vectors. Two vectors having equal magnitude, and same direction are known as equal vectors. They are known as equal vectors. Two vectors having equal magnitude and same direction. Remember. So let me have two vectors here. So suppose this is one vector. Okay. And here I have another vector. Now what do you notice? You notice that these two vectors have same direction. They have same direction, A bar and B bar, they have same direction, but their magnitudes are not equal. Mod A bar is not equal to mod B bar. So A bar is not equal to B bar. Therefore, A bar is not equal to B bar, remember. Okay. Now let me have another vector. Here. See, look at this. This is vector P bar. What do you notice? You notice vectors A bar and P bar, have same direction. They have same direction. And they have magnitude of A bar is equal to magnitude of P bar. So what we can say? We can say A bar is equal to P bar. See, I'm writing vector A bar and vector P bar. They are equal. Vector A bar and P bar are equal vectors. See. Now let me have one more example. See, I take a vector here which is having same magnitude. Okay. I take a vector here which is having same magnitude and I name this vector as vector C bar. Look at this vector C bar. Vector C bar has same magnitude. It has same magnitude as A bar. Vector C bar has same magnitude as A bar. Okay. This is vector C bar. So what I see here, I see mod of A bar equals to mod of C bar. See, their magnitudes are equal. So I have written mod A bar equals to mod C bar. But I notice that the direction of these two vectors are not same. The direction of these two vectors are different. Okay. They are not in same direction. A bar is in this direction. A bar is in this direction. Whereas C bar is in some other direction. You see this? The direction of A bar and C bar are not same. So what you will say? You will say A bar and A bar and C bar are not equal. They are not equal vectors. A bar is not equal to C bar. Try to understand, though their magnitudes are equal, they are not equal because they have different direction. They have different directions. Okay. So when can you say two vectors are equal? When you say two vectors are equal, remember their magnitudes are equal and they have same direction. They have same direction. Thank you.